Okay, chapter 4. Let's talk about this.
That's not what I said.
So I've laid out the opportunities where we could cover material and ask for help. We've got choices between second flex, third flex, and class. Can't do first flex because I've got my tier 3 math kids. Although I would love to do that, and
They won't sit in here and be quiet. Nor will they do their IXL.
So let me write this then. I'll put it up here as a potential, but I'd have to look into something and get permission. Wow, okay, my right ear is ringing. I'd have to get permission first, so I'll leave that there in light gray as a backup. Okay, so what I was looking at, first of all, if you were out Friday, 4-4. We tried to finish it, and it got deep, and we did not finish it, but we worked the entire time. And I'm going to pick back up on it today. So we will finish 4-4 today, and there is a I'm going to say possibly, that we could do that one example from 4-6 today. I don't know. We'll see. But I wanted to float the idea of still having the exam on Friday. If y'all feel ready, we could make the call by like Wednesday. So we need to be prepping for it to be Friday. And then on Wednesday, if y'all are like, this is not going to work, then we'll be like, okay, scrap it. It's going to have to be after turkey break. But you need to keep it in the back of your mind, it's Friday. Y'all with me? All right, which would mean that this day here would be where you're reviewing as a class without me, because I won't be here that day. So that would be y'all relying on each other, like, I don't know how to work number 5. Well, here's how she did it. How did you do it? You know what I mean? That is straight up studying. We have to cover, we have to finish 4-4, cover 4-5, and 4-6. 4-5 is 2 days of material. So I was looking at it and I was thinking, finish 4-4, we could do 4-6 because that's that one type of problem, and then we just practice on 4 problems in the notes. We could do 4-5 somewhere. When do y'all go to lunch? Third? Okay, so we could start 4-5 tomorrow.
Brody has second lunch.
Can y'all switch lunches so that
I just kind of go when I want
the
to.
majority of the class, I think, goes to third? So that my lunch is second, but I'll give up my lunch if it helps us to get to the exam. So we could start 4-5 in flex in lunch tomorrow, second lunch, and then carry through during class, and then wrap it up here. And then this would be review with me. Because that's if we get to 4-6 today. If not, we would do 4-6 here, which is, again, that one problem.
So we would have 2 days for review.
You'd have 1 day with me, and then Thursday you would have where you're just working with each other, have my answer key of the solutions, and then right here on that Friday, you could come to me here and here. You know how we do. You could come to me there if you had last minute questions. I have another idea, and that is instead of doing the practice test on my math lab, we will just do the test. I'll change it to number of attempts 2, so your first time through it would be your review. With me? And then on the day of the test, you would take it again. But it would be the test. Like, no notes, no review.
Would it take the highest?
No, I would, your second attempt would be your test grade. Because your first attempt would be open notes, review right next to you. You know what I mean? Like, instead of going through the My Math Lab practice test as your review, you would go through the actual test one time through, treat it like a review, and then the day of the test, we would do a second time through, no notes.
So we're not getting a little colored sheet for this test?
Oh, I don't know yet. I haven't decided. Possibly.
Okay.
So that's another thing that I thought we could do as well. So that way you have my paper review already,
Yeah, I guess.
but then you would do the My Math Lab
Basically,
actual test. You would be taking the
So we just do the test twice?
as a review. Yes.
why don't we do that?
So
I like that idea. I like that idea.
So y'all want to shoot for this, and then Wednesday we'll decide.
Yes.
Okay. All right. So you need to, in the back of your mind, you need to be, if you were absent Friday, lock in with me right now, because what I'm fixing to do is exactly what we covered Friday, and then go back and get the notes from Friday, because there was some valuable stuff in there. And then we'll do 4-6. And then tomorrow, I will send everyone a 5-star pass for second lunch. We'll start 4-5, carry through during class, repeat Wednesday, second lunch, and that would put us Wednesday in class going through the actual test as a review. All right, guys, 5 days of hard work, minimal leverage, like slacking off, to have the entire week of Thanksgiving off.
I like that
Math.
idea.
So let's do it. All right.
If we don't finish 4-5 Wednesday in first flex, second flex, would we work through third flex?
We could.
Okay.
It's up to y'all. Yeah. I mean, that could be like an added layer of, like, just in case. All right. Look at 4-4. I'll do a crash course up to where we were on Friday, and then we'll go to the new slide where we left off. The whole point of 4-4 is solving polynomials when you don't have a 0 to start with, okay? Also, writing the polynomial function from the given zeros. So this slide right here was, hey, here's the zeros. Tell me what polynomial it could have come from. Well, the only one, they gave both of them. Okay, so we put them in factor form, we multiplied it out, and then we got the answer. This one down here was, now we're changing the multiplicities. So you just had to know to put that, oh my word, that was too much. You had to know to put that power on the factor if it had a multiplicity higher than 1. Then plug it in, multiply it out, and clean it up. I would probably guess everybody's worst part, or least favorite, is multiplying it out. Yeah, multiplying it out is probably the most annoying part. Which led us to the list of irrational zeros. Irrational meaning cannot be written as a fraction. If I said to you, hey, there's a polynomial that has these as zeros, then make your list of the given zeros. You're going to draw arrows to mean like, hey, there's another one there. There's a secret one that they did not mention. You should notice that the only time there is a secret 0 not mentioned is if they gave you one with an I or a radical. Okay? If it has an I or a radical, there is a conjugate 0 that you have to also list. Then, in this case, that's all it wanted. You have to know when it's saying multiplied out or don't. In this case, it just said, tell me the others, which meant list it and you're done. Now, this one down here is list it, now multiply it out. So they gave me these two. This is a radical, this has an I, which means with my arrow, I'm reminding myself, hey, there's more. Change the sign of the radical and the I. Because these look different than what we're used to, follow my highlighter. We said, okay, so x equals this. Now add that to the left and you get the factor. X equals this. Subtract that to the left, you get the factor. X equals this. move that crap to the left, you get the factor. X equals this, move that crap to the left, you get the factor. It's the same thing every time, it just looks ugly because of the I and the radical. And then you put it in factored form, which as much as I would love to say that's all you have to do, that's not the case. You have to multiply it out now. But that is the answer, which is why on this test, I would want you to put that on your answer sheet and then do your best to multiply it out so that if you get the multiplying part wrong, I can give you the majority of the credit for having the correct factored form. Like, that is the answer. It's just not in multiplied form. It needs to be multiplied out in standard form. To multiply it on Friday, we talked about how we have two difference of squares, and there's a pattern when you're multiplying difference of squares. For instance, focus your attention on just these two. Notice they are the exact same thing, but one has a plus, one has a minus. That's a difference of squares. The shortcut is that the middle term will always disappear. So then use the shortcut to multiply, which is first times first, last times last. Okay, so first times first, last times last, and then don't try to clean it up. Just leave it there and get it on the next line. Over here is also a difference of squares, although uncomfortable, because there's three terms in each set of parentheses. What I did with the yellow highlighter was I said, notice how the first two terms are identical. Notice how the last two terms are identical. It's just the sign here and here that's different. That's the difference of squares. So to multiply that out, do the first two. So I wrote it like this. And then do the last two. Negative I times positive I is negative I squared. Then clean it up. That binomial squared is this, which I went over there and did it. And then negative I squared becomes plus 1. Then you do have to multiply the binomial times the trinomial, which brings you to the final answer down there. Which is now you can see why Friday took so long. It was not necessarily the new stuff, it was multiplying that took forever.
I know if we did have the exam on Friday, it would be a normal class time, but what if getting all these forms take
I've got, so how many did you say it said?
It said 9.
So the next exam on my math lab for some reason says 9 points. I need to go in and look at it because I don't remember how many questions total it is. But we do take I do take into consideration the length of time it takes to solve these. I also can say I don't expect you to have to do too many of these. You know what I mean? Like,
Just like
one and done is enough. It's do you know it or not? If I threw more than one and you don't know it, that's kind of unfair because now you're definitely going to get more than one wrong, you know. I'll look into that though. Which brought us to this part right here. I should have saved the one from Friday. It looks a lot better. When you first look at this, you're probably, if you were out Friday, this probably looks terrifying. There was a method to it and there was a process. The process is if I am told, hey, I need you to solve this, but they don't tell me what to start with, there is something called the rational root theorem, which recognizes a pattern in the solutions to polynomials. The pattern is if you create your list of fractions or whole numbers by doing P over Q, your answers, your real answers, notice I didn't say imaginary or radical answers, your real answers will come from this list. And so what we did was we just picked one, plugged it into the function, and we got 0, which meant run with it. So -1 worked, we did synthetic division, we came down to this expression. Well, because it was a quartic, and we just broke it down to a cubic, we had to go again. So we went back to the drawing board, picked another number, plugged it in, got 0, ran with it. Did synthetic division from this set of numbers right here, not the original, because the idea is we're breaking it down. And then we came to this, which is a quadratic. To finish the problem, you have to call on what you learned in the last chapter, the different ways to solve a quadratic. This is that stuff where I said you're going to use an entire sheet of paper to solve one problem. This is that. So the quadratic that I have right here, we noticed every single number is divisible by 3. So we divided a 3 away completely. We noticed it will not factor, so we did the quadratic formula. We found the crap, then we plugged the rest in, and we came to this right here, and then we noticed that that's divisible by 2, by 2, by 2, which leaves us with the answer 2 plus or minus root 2. And then what we were not able to do on Friday was to actually list our answers. And I'm trying to understand what this random stuff is that I have. We went up here, we listed our answers. So we have x plus 1, which came from the negative 1. We have 3x minus 2. Oh, I know now why.
How did you get
3x minus 2.
all?
Remember, if it's 0, it comes from what factor? So, like, negative 1 was a 0, so it comes from the factor x plus 1.
I'm saying when you factored it algebraically, you got x plus 1, 3x minus 2, x minus 2 minus squared. Like, is that?
Those all came from my zeros. Notice x minus 1, if I set that equal to 0 and move it over, I get x plus 1.
Yeah, okay, where'd you get the 0?
Remember at the beginning right here?
I didn't do this.
Oh. Your list right here. This list.
You put it in the calculator and look at the table.
No.
Whichever
one equals 0 lets you know, hey, that
How do we
one
get
works.
that list?
P over Q. I'm fixing to show you how to do it. It's P over Q. It's called the rational root theorem. And what it entails is looking at the constant on the end and the leading coefficient and creating fractions, and that's your list. So instead of trying to understand one that's already done, let's go to this one. Go to this one and let's just do it together.
Sweet boy.
Is that gonna, if I don't want that to fall on the floor. It's gonna drive me nuts. Alright, go to this one right here. Example 6. Alright, here is the rational root theorem. So if I tell you, here's a polynomial, it says find the rational zeros and then the other zeros, which means, hey, solve it. Okay? Is it working? Do you need me to do it on my computer?
You should say yes and walk away.
It's moving.
Huh?
It's working.
I'm so great.
Just go on and just tell them I took care of it. Alright. So we have a 5th degree polynomial that we are going to solve all the way down to x equals something. How many possible answers are we going to come to? 5. Okay. You with me? So, game plan. We got 5 answers to find. How in the world do we find the first answer? You mind your P's and Q's.
Why do you say there's 5?
Because it's the 5th.
Degree?
The degree sets the tone for how many times it can
And there will
cross
be
the x-axis.
4 curves.
4 curves. All right. P is all, remember this part from Friday. It is not in alphabetical order. P is at the end. Q is the leading coefficient. We're going to mind our P's and Q's. Okay, so the first step is to say to yourself, what are all the numbers that divide into 15? Don't forget positive, negative. The easiest way to do this is to count your way up to it. So 1 goes 3, 5, and 15. Now do Q. Q is the number 2, so 1 and 2. So that is just the list of factors of the P and the Q. Don't forget positive, negative. Now to get your actual list of rational zeros is where you set it up as P over Q and you clean it up. Sometimes it'll be a fraction, you leave it as a fraction, sometimes it'll be a whole number. You're gonna, yes? Because 1 goes into 2. 1 is always in the list. 1 will divide into anything. Behind Taylor on that bookshelf. Alright, we're going to make our list of P's over Q's. Keep your non-writing hand on the first P, and then I would use your writing hand to, or your eyes to visualize like 1 over 1 is 1, right? And then 1 over 2 does not reduce. Now we're going to repeat. But we're moving to what on top? 3. 3 over 1 is 3. 3 over 2. Just write it. Now we're moving to 5. 5 over 1. 5 over 2. Now we move to 15. 15 over 1. 15 over 2. Okay, let me remind you what that list means. That list is the possible, not all of them, but the possible real solutions. If you were to solve this polynomial all the way, your real solutions would be in that list. Now there are some in there that don't work. That's why this is not perfect, but it does cover the answers. It's just not the only, it's not all of them. Alright, so we need one to start us off with. It's going to be a fraction. Just to save you on time. So the next step is where you go to your calculator. You can type that in y equals and check the table, or you can just punch it into the calculator. I need you to find a number that when plugged in gives you 0. And it's a fraction. It's a fraction. This is the worst part of it, is having to find a number to start with.
Wait, 15 over 2.
Nope. If you want to change the table to show you the half increments, which is not a bad idea since the only fractions up here are being cut in half, hit second table set. Should be at the top. And then you're going to go to where it says delta table or triangle TBL. That means the change in. How do you want us to count? And I would put it at 0.5. So let me put that in the video if anyone... Yeah, it's 1/2. So I'm not going to type it in the function in because y'all already answered that it's 1/2. You would go second table set, and you would tell it, you can tell it where you want it to start, but you would tell the change in the table to be 0.5. Leave everything on auto, and then when you go to your table, it will count by 0.5. Okay? If you do ask, you have to type it in, yeah. Yeah. Some people like to just see it. Okay, so what's the point of what you just did? You've just found one of your 5 answers. You with me? You just found
Wait.
one of them. So what I like to do is keep a running list over here to myself so I know that, ooh, winner, winner, chicken dinner, I just found one. We just found 1/2 to work. Now, if 1/2 works,
So there's negative 1.
ooh,
No, it doesn't.
ooh, why not?
I don't know if it does.
Remember, the only ones that have like a secret partner
Oh, yeah.
have an I or a radical. Yeah, so
Dang it.
if 1/2 is the solution, what factor did it come from? Now, we've not had this happen before. So let me show you. If you need to, I guess we can put it over here. You would say to yourself, that's x minus 1/2 equals 0, right? I'm having to write small because I've run out of room. If I move it over, notice that all of our factors never have fractions in them, right? Have you noticed that? Okay, so you have to ask yourself, how would I get rid of that fraction? You could multiply by 2. So I visualize this. I would end up with 2x minus 1, and that would be my linear factor. Now, if you need me to show you, I'll show you right here. I have more room over here. This is where we were trying to get the linear factor. We need no fractions. Can't have fractions. So multiply the whole thing by 2. That gets rid of the fraction. Alright, so distribute, right? So 2x minus, you can write this if you want, 2 over 2, but it'd be easier just to say minus 1 because what happens? That cancels, equals 0. You see it? So if you ever have a 0 that's a fraction, be careful writing it as a linear factor. But the good news is, if you had this here, and you set that equal to 0, add the 1, divide by 2, you would confirm that it came from 1/2. You see that? Remember the connection between the 0 and the factor? So keep that in mind. Like if you go through this and you're unsure of yourself, then set it equal to 0 and solve it and confirm that you got 1/2. If you didn't, then you know something's wrong. All right. Good gravy. Okay, so we've just found that 1/2 works. So I like to come over here and say to myself, okay, f of 1/2 gave me 0, so I'm going to use 1/2. Synthetic division. What do I need to check for? Gaps. Come up here and count the exponents down. We got 5, 4, 3, 2, 1, none. So no gaps. Ugh, spaced it out too much. Okay, we're going to do synthetic division with 1/2. Please don't multiply by 1/2. What's the easier way to deal with multiplying by 1/2? Just divide by 2. You're just dividing by 2. Know your math. If I'm multiplying by 1/2, I'm really just dividing by 2. Alright, so here we go. Bring this down. Multiply. Divide by 2. And then add straight down. Then multiply. Write it right here. Add straight down. Y'all remember this? Then multiply. Add straight down. Multiply. Add straight down. multiply, add straight down. Because we got 0 when we plugged it in, we should also get 0 for our remainder. It's a checkpoint. All right. This was what degree? All right, it was a 5th degree. I just solved one linear factor. I just pulled a linear factor out. It's right here. I just pulled one out. So what's this? What degree? So this is a 4th degree, which means this zero's a gap on 3rd. This is 2nd, gap on 1, constant on the end. So I'm going to bring that down. That's 2x to the 4th minus 4x squared minus 30.
Do more.
You do. You have to go again, but let's think smarter, not harder. What am I conveniently left with? The only what type of degrees? Even.
And they're all divisible by 2.
The whole thing. Do you notice every single term's divisible by 2? Do you see that? So let's set this equal to 0 and reduce the entire thing by 2. What? Yes. 0 divisible by 2?
No, so 0 is 0.
Oh no, 2 has no x.
Yeah.
2 is just a GCF.
30.
I'm awake.
Cap.
I'm talking.
CAP.
Do you remember? Y'all are gonna throw your shoes at me.
U substitution. Yes, I remember U substitution. You substitute U for x squared. So it's going to be U squared minus 2U minus 15. And then
Dang, he wakes up and it's like Rain Man.
and you have to find, once you find the U's, you have to sub x squared back in for each U.
Can you stop bugging me?
He just stole my thunder, by the way. This was like my surprise to tell, but I'm very glad to see that you're awake.
No, you threw it at me.
Y'all remember
fuzzies.
last chapter, U substitution for solving higher degree polynomials by reducing them to quadratics? Sadly. Remember it involved rewriting that
Venus.
first term
Happiness.
like that.
And then you change it to
And then you change it to U squared minus 2U minus 15, and it will solve by
No.
Yes.
factoring.
Yes.
I've written too big. I gotta change all this. All right, hold on.
Womp womp.
Y'all quit. All right, so let's keep.
Whoa!
We using that lab voice.
What in the world?
Happiness.
All right.
Womp.
There
What?
we go. All right.
Sadness?
So stay with me right here.
I don't like sadness.
So I'm going to let x squared.
I like happiness.
U equal x squared right here. I'm going to let u equal x squared. So instead of x being in there, I can have u squared minus 2u minus 15 equals 0.
My legs. Too bad I don't. Oh, please do.
You should have chose happiness.
Well, there's a reason that I had you do that before I was threatening violence. All right,
Stop saying happiness.
let's factor.
Funny guy.
Factors of negative 15 that add up to negative 2.
Oh, it's 3 and 5.
Negative 5. And by the way, the u substitution thing, that leading coefficient has to be a 1. So right here, we can go straight to parentheses.
Whoa. Sorry.
So we got u minus 5
Can you stop making loud noises?
and u plus 3. Now pull those zeros out.
Hold up.
right? Imagine those, this is something times something equals 0. This should be familiar territory.
Positive
You
5.
set each of them equal to 0 and you solve. So the u from here would be
Positive 5.
5. What about here?
Negative 3.
Okay, but remember the problem didn't start with u, it started with
X.
x. So this is where that u substitution, you had to go back and, we're going to use yeah, they're not imaginary. Oh yeah, they are, yeah. So x squared equals 5, x squared equals negative 3. If I need x squared to be just x, I would square root it. Now, please don't let something so simple right here give you the wrong answer. Remember, we said how many potential answers? 5 of them. Right
So
now,
we get
you've
plus or
got
minus down
1.
here.
There you go.
Here's your other 4.
There you go. So you got positive root 5. You've got negative root 5. You've got positive root 3i.
What would it be?
I like to put the I in the front, but my math lab wants it at the end. Then you got negative root 3i. So there's your 5 answers. You can't take the square root of 3. So it'll still be under that square root. You're thinking of 9.
I am thinking of 9
If
because
it
I
was
did the same
9,
thing.
it would be positive, negative, just 3i. But it's a 3. Now, I have good news. After all of that, all we've done is list the solutions. Notice the second part says, factor it into linear factors. All that means is, tell me what factors those solutions came from. And the good news is, my math lab does not want you to multiply it out. So once we write them, we're done. So let's look at it carefully. We've already got one linear factor. Come back up here. Let's just go through it systematically. Remember, you're just moving it over to the other side. I went the wrong way because you're facing that way. So like x equals root 5. Subtract that over, and you have x minus root 5. Right?
Yep.
Okay. X equals negative root 5. Add that over, and you'd have x plus root 5. Are y'all following?
Yes, ma'am. And then we do
Then you got this one,
X
subtract it over.
minus root 3i.
It's minus root 3. Watch the I, make sure it's not under the radical. And then the last one, x. There we go. Plus root 3. Arrow out of the radical I. And then my math lab will let you stop right here. So
They will.
MML, stop here. Like, you don't have to multiply that out. They'll let you type that. Just make sure you do arrow out of the radical before you hit that I, because if it's under the radical, it'll tell you it's wrong.
I got my 15.
Now, that's what we did Friday. Now you can see why Friday took a while.
That was doo-doo.
The good news is we are done with the exhausting problems before 4. The last 3 slides are a breath of fresh air. So let's move to them and talk about what it's asking for. Okay. Determine the number of variations of sign in the polynomial function. This is as simple as recognizing when a number is going from negative to positive. Positive to negative. That's a variation, right? Look at this polynomial. I'm just going to copy it here so I can make notes underneath it and you can see my notes. We don't even have to worry about gaps here. Nope, because we're not solving, we're not graphing. We are just looking at variations.
Will this just be 0?
No, this just has to do with the coefficients of the terms. So watch this. So now, first of all, you do need it in standard form, which means counting down, by degree. All right, so from here to here, right? This 2 is positive. Okay, I'm going to draw an arrow. This 3 is negative, which means it varies. It went from positive 2x to the 5th to negative 3x squared. So there's a variation there. Okay, now, kind of did my little thing a little too much. All right, now we're going to go from that term to this term. That's a negative going to a positive. So that varies. And then the last 2 terms, I'm going from the x to the 4. That's a positive going to a positive, which means no variation. I say no, I should write underneath it, variation. It was the same sign between the 2 terms. So how many times total did it vary?
Twice.
Twice. Alright, we have a whole test on this.
Yep.
More?
Doodle up.
Oh my god, there is.
Why wouldn't there be?
No,
These the same song?
With the frizz? No way.
No, they're not.
Cruising down the main street.
I can see her dressing up as Miss Frizzle for Halloween one year.
I could too.
Alright. What if, look at this, draw a line,
I want to listen to Miley Cyrus.
come back to it, we weren't done.
Brody, do we have to live today?
What if we had a negative x in there?
I'm
Like
not
a
working out
negative
there.
0. Remember how many zeros we had a whole list? It was positive or negative. Now, here's where you've got to remember that negative values raised to even powers do what? They become positive. Negative values raised to odd powers stay negative. Y'all remember that? Okay, so let's look at it. If I plug in a negative to the 5th, minus 3, negative x squared,
You'll still only do main street
negative
though.
x plus 4. Alright, all I've done is plug in the negative.
We're just doing
I
bench and
can't really
squat.
look at anything yet until I clean it up. This is a negative base to an odd power, so it will produce a negative with an even coefficient, so it would be negative 2x to the 5th. Do you follow how I got that?
Yes, ma'am.
Okay. This is a negative. Sure, sorry. Stupid crap. Alright. Then this is positive 1 times negative x. Be negative x. Bring down the plus 4.
What about his wiener?
Alright, now we're going to do the same thing we did in the last problem. By the way, I'm just going to draw this arrow down. Okay,
No.
so we're looking at from here to here, then here to here, then here to here. Not necessarily. So this is a negative going to a negative, which means no vary. This is a negative going to a negative, which means no variation. And then this is a negative going to a positive, which means varies.
Well, like up there was 2 varies and then no. Now it's 2 no's and 1 varies.
Yes.
Yes.
You like that? That's what I mean.
I don't know. I find it easier to just check it.
With a freeze?
What? No, it doesn't.
There was one variation.
There's 2 varies and 1 no. Flip flop and boom, done.
You lost me.
That's what Tennessee said to Missouri.
Are you gonna break my chair?
No.
Oh, you
I I'm not.
just got that last.
I don't weigh that much.
No, but you're late. Did you lower it?
Yes.
Okay.
Hey, are we gonna try to finish these? Are these last two slides the same thing?
They're the same thing. So if you look at,
Oh, okay, I understand. I'm done.
You want brain?
yeah, this is positive to negative. That varies. But that's negative to negative, so no. And then negative to positive, so 2 variations right here, right? Through my brain.
Who threw the?
So what
You're
is
supposed to
that
catch
in
it.
the box?
So the box
play center
is, notice the directions
I play center
say,
now.
we're using Descartes'
Center
rule,
on
by
the
the way,
outside.
which he's not that,
What's football?
he's not as important as Pythagoras, I would
Never
say.
mind.
It says, what is Descartes' rules of signs tell you about the number of positive real zeros and negative real zeros? Well, the way it varies is letting you know if you plugged in, if you have positive x and it varies twice, then there's 2 positive real zeros. If you found negative x, plugged it in, how many do you get? You get 1 right here. It means there's 1 negative real zero. So it's kind of like a way of describing the zeros without solving it all the way. Without doing the rational root theorem, without making your list, without doing synthetic division, you can make your description of the zeros. While you pack up, I'll write it.
Already made it
If
easy.
it's a 5th degree polynomial, how many zeros can it have? It can have 5.
So that means that's 2 real.
So you got your positive, right?
Hey, trash.
Real. You got your negative real, and then you've got non-real. And that would include imaginary or radicals. When we did the positive 2, then 1, how many is that? That's 3. How many do I have? So that would leave 2
Hey, you got
non-zero.
There you go.
Oh, just in this.
So if there's 2 positive reals, 1 negative real, and 2 non-reals, it's what is the possible scenario for I don't know how to explain it without spending more time than you don't. I'll show you and then we'll explain it tomorrow. It would be 0, 1, and 4.
Where do you get those numbers from? From the 1 minus x?
Yes. So this number here comes, this number here comes from p of x. This comes from p of negative x. And this is what's left over when you subtract. Now, this number, this set over here is really not even relevant, if I'm being honest. It's the other column that's relevant. And I think I need to go into the homework and remove some of those because they asked way too many, in my opinion.